Hi, Dr.
Hi,
Mosconi. Thank you so much for joining us.
thank you so much for having me. Hold on 1 second.
Absolutely. Get
The
yourself
little
settled.
thing I was using to keep up my phone just broke.
Yes, I know.
So I have this super low tech situation here, but I'm holding it up with basically makeup.
You make it work, right?
It's working. Hi, it's good to see you. How are you?
I'm good. It's so nice to see you. So thank you for joining us at Alloy here. I know you're making your rounds with menopause people and lots of others here on, Instagram, and you're out in Aspen, right? Sharing your brain research work.
Yes, I was in Aspen last week, and actually, I'm told that my session on the menopause brain and this new study was one of the most attended and one of the most
Amazing.
talked about, which I'm really happy. I was really happy to hear that because it's good research, it's new research, it's all about women, women's health, menopause, and honestly, we don't get enough information out there, especially at this level. So I was really honored to be invited. And, the head of the CDC was there, the head of ARPA-H was there, the head of the NIH, Jennifer Doudna was there.
It's amazing.
Like, wow.
Well, and and I think it's really important because as you can tell the audience that we need more research dollars in women's brain health, in menopause, in hormones. And so the people who fund this research, they need to see that people are interested, right? And I heard when you spoke to Dr. Mary Claire Haver, I know you said like everybody download the article. So let's start it off. Tell us the name of your study and that people can open access this article, meaning it's not behind a paywall, which was a really important thing you did so that anybody can get to this, because what happens is a lot of studies are behind paid walls where unless you're a subscriber to a certain medical journal, you don't get to read it, right? But anybody could read this.
Yes. And I think more than anyone can read it, it's not super easy to read, obviously.
No.
Scientific, it reads very scientific, but the
Yes.
reason I please download the study is that it's really hard to get published when doing this kind of work. And so the more downloads and the more people access the study, even if you don't read it, just the fact that you click on it, perhaps you scroll through it, maybe there's some figure that looks nice or interesting, that signals journal editors that this is something that people are really honestly interested in, and that should be a little bit more of a priority. Because let me tell you, I've been publishing for over 20 years in scientific journals, and I used to publish mostly Alzheimer's disease, Alzheimer's prevention. I have almost like 200 publications, which is a lot for my age. So I work really hard. I never had an issue getting published until I started doing work on menopause. And now
That's
Walt
astounding.
and it's very strange because it's the same kind of research, it's the same rigor, it's the same attention to detail, it's the same exact technologies. We're doing exactly the same things, except the topic has changed and is still not considered of general importance. Perhaps it's still considered to be like a specialized topic. So the more people download these studies or try to access these studies, the more visibility this topic gets, not just our work, obviously, but just the fact that women want research
Yes.
on women's brain health and menopause. And that's a strong signal that this is something that, as a journal editor, you might want to invest more resources into and look more into, obviously, good research.
Yeah. Well, this is wonderful because I think the average woman out there, they want to be part of this menopause movement. They want to do things. So here's something that's actionable. You don't have to understand the study because we're going to get into it. It's complex, right? There's a lot of, a lot of scientific terms in here and stuff. But if you can at least show that there's that interest, that's a way that you can kind of vote for more research, right? So we need the army of women to rise up and say, time's up. We need to level up our knowledge here on something that happens to 50% or more of the population, right? We're more of the population. So tell us, I'll let you read the very long, fancy name of the study. So
I
introduce
actually
the
remember
study.
that. I think in vivo brain estrogen imaging by neuroendocrine aging and relationships to cognition and symptomatology, I believe. The
Yes.
study was published in Scientific Reports, which is a Nature journal, and is the fifth most cited journal globally, according to them. It's written on the website, I checked. And I was really happy about it because you do want to have an outreach that is substantial, I think. At least that was my hope. And we also really want to make the study open access and free to
Yes.
download, because I had to shell out thousands and thousands of dollars so that anyone can actually read it. But I think it's
Thank
worth
you.
it. You're welcome.
It is
I
worth
do
it.
it
And
all
it's,
the time. We do it for important studies.
yeah. And because, uh, the menopause transition, we know there's lots of symptoms related to brain health, whether it's mood, anxiety, cognition, memory, brain fog, and we'll get into that. It's important that every medical specialty has access to this information, and that it's not a niche thing for just like OBGYNs or endocrinologists. It should be something that all specialties understand, because they're all seeing women, and women are coming in with these symptoms and they're getting referred to all different specialists. So, and many women, I said in my little intro to this, when I was promoting it, I'm like, doctors are always saying that, oh, this menopause stuff, it's just in your head. Well, it actually is in your head, but physically in your head, and there's things that are happening. So why don't you tell us? So I think the most fascinating thing is that you did something very groundbreaking. You found a way to actually image and capture and get pictures of what estrogen receptor activity is looking like and how it actually lights up differently on brain scans. And then that was a big
Headache.
hurdle, right? So explain to the audience what this study was actually looking at in the brain.
So, as you know, we've done quite a bit of work trying to understand how menopause impacts the brain, women's brains. And I'm going to go back in time to 2019, where we were doing all this research showing that there are changes that occur in a woman's brain as we transition from having a menstrual cycle to not having a menstrual cycle. They do not necessarily map onto the function of the ovaries. So we were finding that this transition that we define based on whether or not a woman has a regular menstrual cycle and then no longer a menstrual cycle does not necessarily coincide with the brain's timeline. And the big question mark was, well, what exactly is happening hormonally in the brain that can lead to all these different changes that we're seeing in gray matter volume, and blood flow, and connectivity, in Alzheimer's plaques, and brain energy levels. And what we know from basic science is that estrogen is not the only important hormone, but it's a great place to start, because there's a lot of preclinical research showing that estrogen, especially estradiol, is so important for brain functionalities in women, from neuroprotection to immunity to blood flow, energy, and whatnot. And so I went to my radiochemistry department. And for those of you who do not know me, I have a PhD in neuroscience and especially nuclear medicine. I do specialize in nuclear medicine, which is a branch of radiology where we use brain imaging techniques to look at the biochemistry of the brain. So not just the structure or the anatomy, but we really want to measure all the different chemical changes inside the brain. So I went to my radiochemistry department and they said, I need a tracer, a ligand, like a dye, for estrogen in the brain. And they said to me, we don't have one. I was like, this is not a great start here, but I can work with that. I said, is it us? Is it the fact that we, a wild-connect medicine, we don't happen to have this tracer, which was very strange because we are a fantastic nuclear medicine department, and the radiochemistry is one of the reasons I moved to Wildcard now, because we're so ahead of the curve. We're affiliated with Memorial Sloan Kettering, for instance. So nuclear medicine is something we excel at. And they explained to me that no, actually nobody has a tracer that works specifically in the brain. So we have some tracers that are basically estrogen labeled tracers that work for estrogen receptors for breast cancer, but they had never been used or validated for the brain, inside the brain. And so I was like, well, this is unacceptable. We need to have the information.
And I love that you say it's unacceptable. And it's interesting because you're mentioning you're working at a hospital, which is a major cancer hospital,
Yes.
which is giving medications to thousands and thousands, hundreds of thousands of women that dramatically lower their estrogen levels. And we have no idea what it's doing to their brains.
You know, that is actually why I was so surprised. Because, as you know, my background, again, is in neurology and Alzheimer's prevention, is in cognitive aging. And when I started working in this field of menopause, I was always like constantly asking, has this been done? How has this not been done? That's usually my you know, when you have a little mantra, why has this not been done? And it happens so often. And yeah, like you said, I mean, collectively, over 160 million women in the United States alone are taking some kind of hormonal therapies, whether it's birth control or hormone therapy for menopause or endocrine therapy for some forms of cancer. There are so many women who are being put on hormones, and we still have no idea what these hormones are doing inside the brain because we cannot measure them. And so I discovered this kind of unmet need that's not just understanding menopause, but more broadly, really mapping out hormones in the brain. So 2019 was a very busy year for us. And in 2020, so we developed this technique. We were able to show that a very specific ligand that is called 18F fluoroestradiol can get inside the brain and map, can really latch onto the estrogen receptors in the brain and give out a measurable signal. I just want to clarify, this is not easy.
No.
It's very hard to get things inside the brain. Any ligands, any pharmaceuticals, the brain is not a sponge. You really have to find ways to find this blood-brain barrier. Endogenous estradiol can cross very easily by passive diffusion, by using specific receptors. Once you start altering the molecule of estradiol, like we do, we attach a fluorine 18 molecule, then it's difficult to actually get through. So anyway, long story short, it took a couple of years, but we do now have this tracer that can get inside the brain, find the receptors inside the brain, bind to the receptors, and then give out a signal where we can extrapolate the information and get these beautiful maps that you were showing before. Thank you so much. These lovely maps of estrogen receptor distribution and density inside the human brain. So that was the first challenge. It was really technological. We needed to develop or perhaps validate or apply a technology to brain studies.
And this, I just want to pause you here, this is very important. So we're going to talk about exactly what you found, but this ligand itself is incredibly important because now this opens up an expansion of using that for all sorts of studies, right? So other scientists, but other scientists can then build on being able to use this to be able to do mapping of receptors and other things in the brain with estrogen, correct?
Yes, I mean, the applications are endless.
Endless.
There's a million questions that people have been asking for centuries at this point around how hormones work inside the brain. And all we know is from rats and rodents and basic science. And we just didn't have any studies in post-mortem as well. But what we want is a signal in people who are alive, right? Number one, you want it to be in humans. And number two, they have to be alive and functioning. So
and a woman, we'd like them to be in a woman too, right? Because we're often not studied.
But this can be helpful for men as well. You know, men have estrogen receptors as well. And also really, I think that this study is a proof of concept that it is possible to measure hormones in the brain. You just have to put the effort. You need to do it right. But the next step would be androgen receptors, right? Progesterone receptors. There's all the hormones that we haven't mapped out yet.
Oh, I'm so excited. There's so much work for you to do.
Oh, so, I think I'm going to stick with estrogen for a minute because this study is 5 years of my life. And by the time this got published, we had already started a number of different projects. They use this tracer to do other things. So hormone therapy. Yes, I know you want to. But also saw a question that was very interesting in the comments. Yes, so we are interested in the functionalities, in the neuroprotective function of estrogen against a number of neurological conditions that affect women more than men. So Alzheimer's disease obviously is my priority, but multiple sclerosis is a big one. Traumatic brain injury, recovery from traumatic brain injury is another one. Stroke, huge. Aneurysms, brain tumors, anxiety, depression. There are so many things that do have a potential connection with estrogen and menopause that have never been visualized in women as we go through them, right? As we experience these risks. Mm-hmm. So there's so much that needs to get done. It's mind-blowing, but it's good that we're starting.
So now, I think before the study was released, I think the idea was that the receptors in the brain might downregulate, kind of go away as we get older, as we didn't need, quote unquote, the estrogen around, and that maybe the estrogen's going away, maybe that was part of causing some symptoms. But you found something very different. So tell us what actually is happening to these receptors during the menopause transition.
Yes. So that was actually a surprise for us because, so the way that estrogen works is like estrogen is a messenger that needs to communicate information to a reader. And the reader, in our case, is called an estrogen receptor, which is a structure that is not fixed in the brain, but is constantly being made by the brain. So this is a very dynamic process that people thought, based on mice and rodents, people thought that this process would end soon after the end of a woman's reproductive life. In other words, you go through menopause, and at that point, your brain, that was the idea, your brain would stop making these receptors because the estrogen is going down, therefore the receptors are not needed. Now, this may be true. The question is, when does that actually happen? Does it happen right after menopause? Does it happen a few years into menopause, which is what most people believe, that you have a window of opportunity of about 5-6 years to start taking hormones after menopause, but after 5-6 years, that's it, because the receptors are gone, and at that point, hormone therapy might increase the risk of certain things happening. This is the framework that we were trying to test. What we found is actually something very different. Like you said, it's a very different story because we're working with women who are 40 to 65 years of age. Some people thought I was crazy going all the way to 65 because
thank goodness you did.
Like,
it's so
you
important.
better stop at 55, right? Because at that point the receptors are gone, whereas we have more of a range. And what we found is that estrogen receptor density, which is a measure of estrogen receptor expression, how many receptors you have, how active they are, this density is actually increased after menopause all the way to age 65.
And when
So we never
start. And when does it start?
It starts in perimenopause, so late 40s. In our population, I think the average age of our perimenopausal group was something around 48. So we find, if you scan, we have 3 groups of women. We have a group of premenopausal women, perimenopausal, and postmenopausal women. Okay. All the premenopausal women were scanned around ovulation, which is when estrogen levels are high. So the fact that we're not seeing receptors at that point might be that receptors are taken. There's estrogen, they're happy, we don't see them, they're gone, they're doing their thing. But as estrogen levels start to fluctuate in perimenopause and then bottom out after postmenopause, the idea was that we would find an inverted U shape, where at some point the density goes up, you have more receptors, and then there's a crash. And we're not finding the downward slope. We're still looking at increasing levels at this age, which suggests that the brain is actually quite receptive to estrogen because there are all these receptors that are ready to grab it.
Like hungry for low levels of estrogen, right?
To me, that is a brain that looks hungry for estrogen. And of course, it needs to be replicated, validated. What happens if I give you the estrogen? Do I see fewer receptors? We're doing it now. But the bottom line is that we don't find fewer receptors. The receptors are there. The brain is functioning, is making the receptors, which suggests an active need to fill these receptors with something, most likely estradiol or some other form of estrogen. And the other thing that was really important to us was the correlation with clinical symptoms.
Interesting.
So, yeah, I thought, wow. So we are trying to understand the neurophysiology of the cognitive symptoms of menopause. So when women come to us saying, I have brain fog, I can't remember information, or I have these mood changes, I have low mood, I have the doom dumps, right? Or I can't come up with words, or maybe it's the anxiety, the depression, also the sleep disturbances, not just the hot flashes, actual neurological symptoms. Can I predict them? Can I find out, is it really estrogen withdrawal or estrogen decline that is causing the symptoms? Is it something else? And can I use this brain test to predict whether a woman will have the symptoms or not? Because you can't do it with blood tests. There's no correlation between hormones in blood and hormones in brain. The brain is its own show. So there's a separate ecosystem, hormonal ecosystem.
And can I just stop here and ask you, because I think that was an interesting piece of your research, was that you saw that these receptors were better at predicting the menopausal status than even serum levels, and that these receptors seem to be kind of showing themselves more even in the perimenopause, when we know estrogen levels are still present,
Yeah.
and but just fluctuating. But the brain's almost like ahead of the curve and is
Yeah.
like, no, we're upregulating now. We're gonna like express more of these receptors, which is so interesting to me as a clinician. You know, I'm not a research scientist, but I see the clinical side of things, and that the number one complaint that perimenopausal women have is not hot flashes, it's mood changes, it's brain fog, it's anxiety. So I thought that that was super interesting that you saw this association, correct?
Yes.
Yeah.
We were very surprised. So hormone levels in blood, at least in my hands, do not predict anything. There's no way to use those measures to tell, even just to tell if a woman is definitely in menopause or not, because they fluctuate so widely from day to day. So the early postmenopausal stage is really hard to characterize based on blood tests, unless you have a specific, you know, if you're younger, if you don't have a menstrual cycle. But for the average person, blood tests are broadly useless diagnostically, or at least prognostically, right? Whereas the brain signal, the estrogen receptor signal in the brain, number one, we were able to use it to differentiate women who had the menstrual cycle from women who did not, with 100% accuracy.
Amazing.
Yeah, there was almost like, actually there was a net separation between the two groups, which was encouraging. It means the signal is strong, statistically. And then we have a strong correlation with memory function and mood. So the higher this estrogen receptor density in very specific parts of the brain, the lower those women's memory performance, and the higher the chance that they would have the brain fog and or mood changes, like low mood, disturbed
And
mood.
none of these women were taking estrogen, right? I'm assuming
No.
these were women who were without. And so, and when you, well, so download the paper, because you can click on the images. And I think for the average reader, woman, or doctor out there, your images are worth 1,000 words, right? They're really beautiful demonstration. And it's like, you can't ignore the changes that you see. And then the symptom correlation, you have these really pretty charts, the little lavender charts with the stronger purple colors, is more receptors are being expressed and more symptoms, these cognitive, right?
Yeah.
So it's
more receptors, more symptoms, which again suggests that there's something that needs to be addressed.
yes.
Right. So now we're trying to do that. We're working with women who are taking estradiol. Yeah. And our postdoc actually is working on the images right now. So I'll let you know as soon as I can if taking estrogen lowers the amount of estrogen receptor. Are we feeding these brains correctly? And does that have a positive impact on memory and cognitive function and mood? That's our next step. And also we're looking at associations with Alzheimer's plaques in the brain, because we we're testing this hypothesis that changes in estrogen concentrations may be a trigger for Alzheimer's disease in some women. But that, again, it's never been done in humans. It's all from mice. So that's another next step.
There's a lot
Come
of
join us.
brain.
Come get brain imaging.
And so will you tell the audience that, you know, like we hear a lot now with some, you know, there's some new medications, these non-hormonal medications that work on the brain for hot flashes. And, you know, hypothalamus, we know that the pituitary gland really lights up. I think you called it like a supernova, it really lights up. But for women to understand, it's like many areas of the brain where you saw light up, right?
Yes,
it's
yes.
not just one area, it's a lot, right?
So this is also really interesting. We know from animal studies and postmortem studies that estrogen receptors are everywhere inside the brain. But the idea was that there were a few brain regions with a lot of receptors, and then the rest would have just a tiny little bit of receptors. What we're finding in humans, which again is the first time, we're finding that there are more brain regions that have a lot of receptors. There's obviously regions that have just a few, but there's a lot more brain regions that show a significant amount of estrogen receptors just by eyeballing the scans. And then we have them in figure 1. I wish I could show you, but I think you can see where these estrogen receptors are, which is a little bit everywhere in the brain, and then in some specific parts, they are clearly more abundant, which was very interesting, like the thalamus, basal ganglia, this kind of integrative brain regions, and especially in brain regions that are important for memory function, like the medial temporal lobe, but also the posterior cingulate cortex, the precuneus. It's one region that is impacted early on in the brain, already the perimenopausal state, suggesting that there is this kind of, there's a reason that women have a hard time with memory and with, you know, with the brain fog. There's an actual biochemical or neurochemical reason for it, which I think is really important for validation purposes. Because like you said, so many concerns that women express around their brain health, cognitive health, mental health are so often just dismissed. Like, oh, you're just having a bad day, you must be PMS, something like that. So I think it's really important to have science to back up what women have been saying for hundreds of years and say, look, we're not making this up. There's an actual change, there's a measurable change that's impacting a big part of our brains. And to be clear, we function anyway.
Yeah. We could, and so I think there's two important points that always come up when we talk about this. And certainly as a breast cancer survivor, and you're talking to a lot of breast cancer survivors out there who maybe can't at this time or have chosen not to, that they can't use estrogen in menopause, and that's a separate conversation, but they think, well, oh, am I totally like, you know, left out, and am I screwed? Am I really screwed? My brain's, I'm going to really be, you know, at a disadvantage. And yes, we can all talk about how important estrogen is, but it doesn't mean that all is lost. So I want to keep it a positive message that yes, we're very interested in using estrogen and that it has an impact. It's very validating and we want to know all the uses. But if for some reason you can't use estrogen, it doesn't mean you're going to definitely get dementia or that you are not going to be a productive cognitively, you know, well person, right? So what's your message there?
Yes, I think I wanted to talk to you about. There's a study you need to look up, and I will send you the link because it's specifically about breast cancer and aromatase inhibitors and estrogen blockers. Is the study that just came out a few months ago that shows, I get this question all the time, because if you're on breast cancer medications, then the concern is these medications are blocking the estrogens in my brain besides the rest of my body. It turns out they do not. This is very interesting. So tamoxifen especially is a selective estrogen receptor modulator, which means it blocks your receptors in some parts of your body, specifically breast cancer, ovaries, and whatnot. But it doesn't do it inside the brain, which is really puzzling in some ways. And again, it speaks to the fact that the brain has its own game going, right?
Not
So
everything gets through the brain either, right? I mean, it's the
right.
blood-brain barrier. Not every drug's getting through.
Well,
And
tamoxifen does.
it
It
does,
does get,
okay.
but it seems to work like an agonist
Yes.
for estrogen, not an antagonist. So what happens with chemo brain is that the chemotherapy can negatively impact memory and perhaps also the endocrine treatment for a short amount of time. But in the long term, tamoxifen is actually an estrogen agonist, so it supports estrogen action in the brain, not the rest of the body. It does its own, it does what it's supposed to do.
It's selective. In certain places, it's acting different.
But it does not seem to lead to issues down the line cognitively. So I think that that's a
But aromatase inhibitors, what's interesting is aromatase inhibitors are working by further lowering any circulating levels of estrogen. So they're very different medications. I feel like often people lump them together. They're very different, right? And so the aromatase inhibitor is kind of starving the body of estrogen, really,
but not
essentially.
necessarily the brain. And there's one type of steroidal aromatase inhibitor. I will send you the link to this study because they show exactly the same thing, that actually does not block
in the brain,
inside your brain. So the production of estrogen in the brain seems to be relatively unaffected in the long term, which could be good news. And again, I want to see with the imaging that we're doing, but I think that that's important information to have because I don't want anybody to fear.
And your research will be helpful so that in the future we can have other scientists, people look at how can we image the brain. So getting back to, you know, that we now have a ligand and a proof of concept that you can measure and scan and take pictures of what's happening. So what are some future things that you think your study is going to, in the near term, really start to impact? Like,
I'm hoping clinical care. So we need to better understand what happens with hormone therapy, and we're doing it right now because I think if we can, and again, I don't know what the data shows because I haven't looked at it yet. Maybe my students can can send us a comment or something. But if we can show that estradiol can feed these receptors and make them happy and saturate them after menopause, and that correlates with an improvement in symptoms, I think that would give brain people, brain specialists, and other menopause specialists important information to reconsider what to do at what age, right? Even just the dose. How much do I need to make your brain happy? Because that's most likely a different dose that we need from the neck down. And we don't know because it's never been
the dose. We just know there's a range of doses that we've approved for hot flashes, and that's fine. But we don't know what's the ideal dose for the heart health, for the brain health,
well,
you know.
That's the other thing. I haven't tried yet, but I wonder if the same tracer, or perhaps other tracers that we're going to look at develop, could be used as a total body scan. It doesn't have to be brain or breasts. You know, we have total body scanners where we can look at the entire person.
Oh, it's so interesting.
So I would really love to look at estrogen receptors in the heart, in the lungs, in the bone, everywhere there are estrogen receptors, in the bladders, a little bit everywhere. So that's an important thing. And another thing we're trying to do, so we're looking at estrogen therapy, we're looking at Alzheimer's risk. We're happy to share whatever we know about this technique with other neurologists who are looking at multiple sclerosis, brain tumors, stroke, and whatnot. But then what I really want to do is surgical menopause, because in my field, a lot of people don't quite believe or perhaps don't realize the impact that oophorectomies can have on brain health. So if you know anyone, any woman who is planning to do an oophorectomy, and if they would like to come work with us, it's 100% covered by us research funds. It's completely free to participants, but we're trying to do brain scans before and after an oophorectomy, while also obviously providing counseling and support. We do cognitive testing, we do blood work, obviously state-of-the-art brain imaging. We do a lot of thorough questionnaires and follow women over time. because I think we have to have hard evidence that going through surgical menopause is not the same thing as going through menopause more slowly over time, which is a challenge already. But just imagine going through it very quickly. Then you what that do to them. So I really feel very strongly that, again, it's never been done.
It's really, it's maddening. And well, I think that it would be really interesting to reach out to the BRCA previvors. These are women who don't have breast cancer, and they're prophylactically planning. So it's good because they're organized, they're planning it. They know they're taking those ovaries out to, kind of lower their risk of ovarian cancer.
Yes.
And there's a lot of those being done at the hospital where you work.
Oh, I know.
So they should refer the BRCA previvors to you, because they're planning, okay, I'm doing my ovaries out in June, whatever, so they could come in and get their brain scan before and after, and they really are motivated to kind of further the science, because that is the concern, that their menopause is different because it's abrupt. The brain doesn't have time to adapt, where I think what you're kind of explaining to us is that this starts all the way in perimenopause, when you have natural menopause, that the brain receptors have all these years to kind of upregulate, change, like you say, pruning, rewiring. Lots of things get to happen in the brain, right? During the transition. But when it's abrupt, there's no time.
Can you imagine? I mean, it has
well,
to
I can actually.
like, whoa.
Yeah.
And then it's really quick. And this is being mapped out. And so clinicians just don't have hard evidence of what the impact might be. So we're working really hard to provide this evidence, because we think it's so important. And we do work with the OBGYN department at Weill Cornell Medicine. We're working with their colleagues in surgery and oncology. But if anybody else out there would like to join, we have room, we have funds.
Okay. Well, you're going to send me the link, because I'd love to promote that, because I think there's a lot of us on Instagram who are talking about the unique needs of women who are having to do surgical menopause, not for cancer, just for benign reasons. There's 1 in 8 women, people don't realize this, 1 in 8 women will lose their ovaries for benign reasons prior to the age of natural menopause. 1 in 8. So could you imagine we were chopping off the testicles of 1 in 8 men and we didn't know what happened to the brain? But that's what we've been doing to women for literally decades, right? And this is not cancer, this is benign stuff, right?
Prevention is key, really. But the way that we do prevention is very organ specific.
Yes.
So we're thinking, cancer, ovarian cancer starts in the ovary, we get rid of the ovaries. Or you may have a genetic mutation, let's just get rid of your breast and ovaries. And that is not to say that you shouldn't do.
No, you should, but we should.
What's missing is the systemic connection with the rest of the body that has not, to be fair, it has not been conclusively shown. And I think that's something we have to do, and we have to do it fast. Because once we have the evidence, then the field can change.
Yes.
And that's what we're trying to do. Basically, I have a long checklist of all the things that have not been done, that should have been done. And we're trying to
check the boxes.
The more women sign up for the research, faster we'll have answers.
All right. So we're gonna. That's all right. So that's our next mission here. We need to just get lots of people to come and get brain scans if you're planning on getting your ovaries removed. So that's a great call to action. No, because women want to be involved in making the positive change. So today you can click on the article, you can download it, you can, enroll in your research. We'll provide that. On Alloy's stories and on my stories, I'm going to repost the images, because I think it's really fun for women to see. So look at the image, but then go download it. And I think that, I think we all want to thank you. I feel very emotional about it, that you're doing this research, because, there was this is very sad, there was a leading, supposedly OBGYN menopause specialist in Australia, right, just a couple weeks ago, who said there aren't 30 symptoms of menopause. There's just 30 reasons why it's hard to be a midlife woman, job, stress, careers. And honestly, the menopause of like-minded doctors, we were like really horrified by that, because actually there are many symptoms, and you just named a lot of them that your own research is showing is physically happening, is correlating to physical changes in the brain. So to just write women off that there's things that are just happening in midlife, that's why you're having a hard time. No, I mean, that could be true, but there's also physical brain changes that are happening,
Yeah.
right? And so just that alone is very validating for women.
I
It
hope so. I really
is.
think that the validation factor is helpful, and it's hard to symptoms are tricky to measure. They're very hard to measure. They're hard to correlate with anything because the measurements aren't quite there. And that's why we're trying to use objective biological measures instead. Yeah. We're trying to find the correlates and then really focus on the substrates, right? Because that's what in the end, that's what you want to address. It's not necessarily the self-reported symptom, but is what's creating that symptom and that self-awareness and that feeling that, oh my God, I'm just not myself anymore and things have changed. But then in the end, the goal is to intervene on the brain. Yeah. And we always say that menopause is a renovation project on the brain that we're trying to understand and map out. I can guarantee menopause is a neurologically active state. And if you or any person has ever been through puberty or pregnancy, menopause is not that different in terms of its impact, right? We just somehow do not believe that women may have a hard time because it's very strange. So we need to change this field a little bit. And there's so much stigma and there's so much bias around women's brain health and women's mental health. And I think that we need a group of people who are devoted and really committed to addressing these issues and do it in a way that is objective and rigorous and careful, but that is happening, because I think that the research just isn't there. The framework isn't quite there, and it's updating. Whatever framework we have really needs updating and integrating across disciplines. And the more women demand this information, the more women stand up for the missing research and whatnot, and really we move things along. I mean, look at the government right now. Yeah. Menopause moonshot for ARPA-H, which is huge, and the NIH is coming to the rescue. There's an understanding that women have been let down, and we owe ourselves centuries of research that has not been done. So this is a good time. It's a good time.
On the comments, a lot of people were saying, I'm gonna, they're tagging their OBGYN. Someone tagged Kaiser Permanente, the health group, because a lot of women are going to doctors and they don't believe them, and they're just putting them on SSRIs, antidepressants, for their brain fog when SSRIs can cause brain fog as a side effect. So, having your research showing, no, there's physical changes that are happening in receptors, and we can map this out, goes a long way to, make doctors say like, oh, maybe what I learned in medical school 20 years wasn't the whole picture. We need to learn a little bit more.
Brain fog is tricky. Brain fog is really tricky to quantify and characterize. Yeah. I'm not surprised that doctors don't know how to address it. Also, it's a neuro symptom, right? It's not an OBGYN symptom. So we need the research, we need more clarity, we need more knowledge, and then hopefully we'll get treatments that are very specific for those symptoms as well. But we need I think everybody agrees we need the research first. Yes. And then we can talk about how to fix things better, right? And in the meantime, we have solutions. Mm-hmm. And I think education, like what you're doing on your social media and in your platform, that's so important, because there's a lot of fear still in the fact that the guidelines were updated 2 years ago. It takes time. Okay. It takes time to take place, and it takes a long time for research to be even just acknowledged for clinical.
5 years of your life, right? Just this one study. 5 years. So, so thank you from Alloy. Thank you for joining us here. Thank you for your books. Anybody who doesn't know needs to, you've got 2 books, the XX Brain, the Menopause Brain. I tell women all the time, it's on my homework list for my own patients, because I really think it, you know, really helps explain what's going on in your body. And women just want to know information about what's happening in their bodies. And then they can make good choices for themselves when you give them good information. So Dr. Sharon Malone always says that at Alloy. If you give women good information, they'll make good choices, and good information can then be passed on to their doctors. So you're really providing that, your books, your research, and your time on social media. Thank you so much. Anything else you want to say to the audience?
I just want to say to be kind to each other and be kind to yourselves. I find that there's this tendency sometimes among women to not uplift each other and not help each other. This is the time and age where women need to come together and really support each other and help each other out. And I think that's the best. For me, that's been the best experience, to meet you and to meet Mary Claire and so many other professionals and so many women all over the world who are really, really just championing women's health and menopause and want to support us and be part of a community that is going to move on together. I'll just remind everyone that women's rights, women's health was a direct consequence in the change of women's rights and the other way around. So not just medical, it's also public health situation that we need to address. And it's really important that we are in it together.
Yes. Right? That's a wonderful way to end it. Dr. Mosconi, thank you so much. Everybody follow her, download that article, and we are looking forward to seeing what other research you bring to the world.
Absolutely. And I'll text you guys as soon as I have data.
Okay, that sounds amazing. Thank you so much. You have a great day.
You too.